Hello, calculus fans. Let's test the series -1 to the n over n squared plus 1 for convergence. And let's try the ratio test and we'll see what happens. So the usual sort of thing, we want the limit of the absolute value of a sub n plus 1 over a sub n. And we'll plug everything in. One thing to note is that these minus 1s are going to just disappear because they're on the inside of absolute value. So we end up with the limit as n approaches infinity of n squared plus 1 over n plus 1 quantity squared plus 1. Multiply that out, we get the limit of n squared plus 1 over n squared plus 2n plus 1. And again, as I've said before, time to be a grown-up about limits. Instead of using L'Hopital's rule or dividing top and bottom by highest order term, let's just look at this and we should be able to know what the limit is. We'll just take the quotient of the highest order terms. So really we just care about these, so we get a limit of 1. This is the step right here I think we can stop doing. Now we get a limit of 1. Actually, that tells us that the ratio test is inconclusive. It just means we don't know. It might converge, it might diverge, we just don't know. This series is actually better suited to the alternating series test. Now, if your series contains exponentials or factorials, ratio test is probably going to tell you something useful. If your series has no exponentials or factorials, and all it has are algebraic functions, logs, and roots of these types of things, I think you'd probably be better off to try another test. So the series that we started with didn't have any exponentials, didn't have any factorials. After a while, we'll start to see those types of series are sort of useless with the ratio test. Okay, that's all for now.